Again, welcome and thank to Luke for arranging this. Really happy to be back on the community stage. I'm Matteo, like I was introduced. I'm a group manager at Avanade UK and Ireland for software engineering, and I lead the DevOps vertical inside software engineering at Avanade UK and Ireland. I'm also Microsoft MVP for Azure DevOps now. I used to be Team System and then changed name for a while since 2010. You got my blog and my Twitter account here. Feel free to reach out anytime. I mean, I really enjoy when I have questions or debates on anything really. So I really appreciate your time. So let me just okay. So first thing that is worth mentioning, Git changed everything here. Okay, so we're talking about pipelines as code tonight. We are talking about that from an Azure DevOps perspective, but I actually added a twist to it, and I'll talk to you about it in a moment. So thinking about the broader industry, the software development industry, the broader software engineering industry, Git changed completely everything. It was a massive revolution, and it was not just for version control, because I know of so many companies and so many things that at the moment are running off Git. Okay, so if you think about it, the GitOps or any other Git-related movement where everything is stored inside a Git repository, the whole concept of having artifacts that you can store in a Git repository, not tied to a database, but just being, a folder effectively on your file system. You can move it away, you can bring it on, you can share it. And then obviously the revolution of GitHub and the fact that Git right now is the de facto standard in software development world. That talks volumes for someone who, when was a teenager, played with Visual SourceSafe, with SVN, CVS, you name it, then moved on to the Team Foundation version control bandwagon back in the day, because it was honestly a very big improvement compared to SourceSafe, where you had to fix the repository every now and then because suddenly got corrupted by itself, don't know by itself. So Team Foundation version control and centralized version control system on its own were the standard, and everybody were using them because that was the way that we used to do version control at a big scale. Nothing wrong with it, but Git changed literally everything. And with the distributed concept as well, having the opportunity of working with people remotely, without a centralized database, without bandwidth issues, without anything that's constraining the developer, obviously it's a big plus. That led to the new role being SCode. Right? So think about it. Infrastructure as code, configuration as code, pipeline as code, policy as code. I can go on and on and on. Everything nowadays is as code, and for good reason, because you will ensure traceability. You will ensure that everything that you have inside your version control system is going to be versioned, is going to be controlled, it's going to be managed by a set of policies. So pull request policies, approvals, you name it. And it means that in case you really need it, you can move it around easily. You're not reliant on a database. Yes, Git is in essence a database of commits, but when I talk about database, I talk about a relational database. I'm talking about SQL Server, Oracle, okay? Big stuff that you can't really easily move around. So with this new role as code, there is obviously a big change, because thinking about it, it's not just version control system, but it's infrastructure as code, right? So infrastructure as code, you move from clicking on a UI or writing scripts that will configure your infrastructure in a certain way. I think back in the days, the configuration scripts on servers, that was configuration as code. It still is configuration as code, but there are products that handle configuration as code now. Infrastructure as code, ARM, AWS CloudFormation, you got Pulumi, you got Bicep, you got a number of things, Terraform, can't forget about Terraform. You got a number of things that do infrastructure as code. So why not pipelines as code? Why not doing that as well? Why not storing our build definitions, our release definitions, our pipeline definitions directly into version control, so that you can be up and running anywhere if you clone the repository, so that you can maintain an easy historical view of what happens to pipelines and so on. So all nice and good, but how is the industry getting along in all of this? Because yes, the whole world is moving to SCode, but it's a big change, isn't it? It is big thinking about that. We have stuff that just ruined the effect, but cruise control natively supported pipelines as code since 2001, quite ahead of times. But thinking about it, it's a big change for people and developers and organizations that are used to UIs or they are just used to APIs. Having something that you can store as an artifact in the version control and is going to be interpreted as another type of artifact outside of version control is a very big thing. So cruise control 2001 natively supported them because the config XML they used to run off cruise control meant that you could configure all of your pipeline off an XML file. And I found the original SourceForge link to the documentation explaining what the config XML was. Brilliant. And how about the rest of the market and the rest of the industry in 2021? Azure DevOps, GitHub, Jenkins, Go CI/CD, Concourse, you name it. Everyone are going there for pipelines as code because it is effectively the future. And think about it, pipelines as code. We're going to talk about YAML. See it as an investment. Investment in something that you can do in the future, because I had to learn YAML because of Azure pipelines and Azure DevOps, no shame in that. Now I know that my knowledge of YAML can be reapplied to GitHub, can be reapplied to Kubernetes, can be reapplied to a huge number of other tools and other technologies that might be completely outside version control and ALM. I saw something popping up on the screen, so I assume there is a question in the chat. Excel Deploy now is also available as code. Thank you, Michelle. Yes, so another tool, another product, another platform that gets available as code. Now, I'm not here to sell you anything, but thinking about it, if the industry is moving away from UI or APIs, well, the APIs will still be there, but in a different form. And they're moving on to a form of consumption that's based off code, because it can be used by automations and it can be, it can be replicated at scale and so on and so forth. That talks volumes. So it's an approach that's worth looking into. Talking about Azure DevOps and Azure Pipelines in particular, Azure Pipelines fully supports pipelines as code. YAML, nothing out of the ordinary. And what's really interesting is that it's the same engine that runs the traditional pipelines. So if there is anyone using Azure Pipelines and Azure DevOps today with the traditional classic visual pipelines, they will have the same tools, the same tasks, the same marketplace to look into for pipelines as code. It's literally a different entry point. There is no other difference. There are some different features though, because obviously the pipelines as code experience is newer or has got something that's exclusive. We'll touch on them later on. But in essence, what you are interested in is that this pipeline over here with one job, with six tasks, and within this definition can be replicated like this. And it is exactly the same. Because if you look at it, the trigger over here, it is for master, here it is. You can also specify the repository if you like. Now, the repository here is implicit, because obviously this pipeline lives inside a certain repository, which is parcel limited here, parcel limited MRP here, but it's something that you can specify. Then every parameter and variable, you can specify that. Steps within a job, in this case, the job is explicit, but you can see there is a direct one-to-one map between Nugget tool installer version 1 and this task over here, or this VS build task and this over here. It is literally the same engine. All right. So it's really, really important to remember that having pipelines as code doesn't mean the world is going to stop. You have to change everything. And that preempts the next slide. Question that I usually get when I talk about it. Oh, so should I migrate everything today? Should I start a huge effort to migrate all the pipelines that I've got and move away from it, from pipelines, from Azure pipelines in a traditional format, pipelines as code. No, you don't have to do it. All right. And that applies to releases as well. So pipelines as code as a concept means that Azure pipelines simply becomes an orchestrator, and you can do build or release. So you don't have to worry about the difference between build and release. Now pipelines are unified. The new engine, well, the new engine, let's say for simplification, runs both build and deployment jobs, which are the new equivalent of releases. So you don't have to worry about having to run different things or anything. As soon as you go on pipelines as code, then you will be able to take advantage of it. Support, of course, is extremely wide because the tools aren't changing. The marketplace is still the same. Extensions are still the same. Tasks are still the same. So you don't have to worry about this. And you also have some interesting feature for VM, platform as a service, and container, which we'll see in a moment. But they're fully supported. So you literally don't have to worry about support. Now, enough with the slides. Let's take a look at some examples. So what would it take to move from a classic pipeline to a full YAML CI/CD? Is there any question up to now? Let's see if I can bring the questions on the side. I might be able to, yes, bring the chat. Is that groovy like Jenkins? What do you mean, Michelle, by is that groovy like Jenkins? You mean the SCode technology?
I mean the YAML file, is that a groovy syntax? Because I use Jenkins, and that's groovy syntax.
Yeah, there are different syntaxes, and I'll talk about that in a moment. But yes, effectively, YAML is YAML. Then the syntax obviously makes the difference, but learning a different syntax doesn't change the fact that you know YAML. Sorry, I didn't see the question before. Based on Ansible, another syntax, another version of YAML. Someone is going to throw in Kubernetes as well. Again, different syntax, still YAML. As long as it's YAML and you learn YAML, it's easy to move from one to the other because effectively it's just syntax, but YAML is YAML. Right. So I'll keep the questions here on the right-hand side so I can see them as they come. Oh, there's another question. Are there converters to go from GitLab build pipelines to Azure DevOps? Good question on this. I'm not aware of any. There might be one. I know there is one in development between Azure DevOps and GitHub. It's an open source project that's available freely on the internet. But when it comes to migrations, like you suggest, Alex, I would recommend to actually look at the pipelines and look at what they're doing. Because I've been in the situation of doing migrations, and doing a one-to-one lift and shift doesn't really add much benefit, because then you might have to change something. You might have to fix something else. So if you look at the pipeline, you go back to the drawing board, you isolate what the pipeline is doing, and then you migrate, chances are you're going to yield a better result. So let's pick up a pipeline, any pipeline. This is a legacy pipeline. I'm sure you're all familiar with this, and I'm not going to go through the tedious process of showing you step by step how you can migrate from traditional pipelines to pipelines as code, for a simple reason. Back in the days when this session was originally designed, you could only export the various YAML definitions for each single task. So if you see here, you have for each task a view YAML button. This view YAML button is going to give you a working syntax and a keyboard-friendly view of what you're working on. So if you need this task over here, you can click on View YAML, you copy the task, and you can paste it into your new pipeline as code. The beautiful thing is that Microsoft thought about that, and they now add, well, they fairly recently added, I don't remember the date if I'm honest, but they added a View YAML button and export effectively directly on the job. So if I want to migrate this lot of things over here, obviously I can't pick it up directly from the pipeline here. I can't pick it up from the source because there's nothing here that refers to pipeline steps or anything. but I can get the whole job, view YAML, and I will get something that's in a good state to work, okay? So if you want to move, this is your starting point. This is where you start moving things around, okay? So job by job, you will have the various tasks and the various steps. Now, all of this, you see Gradle, copy files, publish build artifacts, and whatnot. Those are all existing tasks that exist as your DevOps and the marketplace. The only thing that you should change here is changing the pool, ideally. Which means that moving to a pipeline as code experience, let's see if I pick up the right pipeline as code. Let me pick up one here first. This is what pipelines as code look like once they've been migrated. So you see, I changed the pool because I'm just using one of the agents from Microsoft. I'm referring to an external repository because I need it, not because I have to, but just because I wanted to build exactly the same source that it's in a different place. You see that it's pipelines as code / parcel limited MRP, which is not the same repository that my pipeline is in at the moment. And if you look at the traditional pipeline over here, you will see that this pipeline is pointing at that repository. It's pointing at parcel limited MRP and not pipelines as code. So that's how you move from one to the other. Then I created a build stage that I call CI, where I have a job called build, and it contains all of the steps that I literally copied and pasted across. All right. So that's literally it. Now, if you want to do something more and you want some help, because chances are that if you never did it that way, you don't know that dash task and whatever is the syntax, then you can pick up your pipeline, and I will pick up one. It should be this. Yes, so this is the same pipeline that we're working with, but I opened that into the editor on the web. The reason why I found it very interesting is because I get this task assistant here on the right-hand side, which is extremely powerful, and we will use it that in a moment, but I can also validate my pipeline. So if I make a syntax error of any sort, obviously I will have something over here that tells me that, but then if I look at the validation, oops, there's an unexpected value, line 19, column 7. Also, if I want to know if I want to know what are the settings that are available and I want to change them, I don't have to go at documentation or finding out from GitHub if it's a third-party extension or whatnot. I can just click on settings, and that will open the same experience that is available on the legacy side. If I pick up this over here and I put it side by side with my Gradle experience over here with some help, so I will see that this is, oops, sorry, wrong shortcut. So I will see that those options here are exactly the same as the ones that are available over here, because the engine is the same, the task is the same. You see it's version 2 over here. It's exactly the same stuff. I don't have to worry about learning something new. I can literally move it across as needed. And what if I want to add something else? Well, again, task assistant. So ideally, if I want to add, that's where the editor is not helpful, unfortunately. But if I want to add, let's say, a PowerShell task, the simplest thing I can think of, I can add a PowerShell task, can enter whatever is the script that I need, or if it's a file that I need to run, the arguments and so on. I will write my PowerShell script, I'll select where I want it, and then I will add it. That's it. Added, and with the correct syntax, with the correct indentation, with everything correct, so that I can trust my editor. Now, this editor is not just a simple experience. This is Visual Studio Code. So if I need to write something, and for example, I have something that's misformatted, which happens, unfortunately, with YAML, I can just run the format. No, there should be a format option. Looks like it's been removed, but there should be a format option. Or if I need to comment something, F1 and comment. This works. So this is Visual Studio Code behind the scenes. It's nothing new, nothing custom, nothing out of the ordinary. It's all stuff that you can do fairly easily. So that's literally the easiest path to move a pipeline from one side to the other. Any question? No questions? Straightforward? Oh, so we can go into the deeper stuff. Okay. So before we go into the deep stuff and the advanced features, I just want to talk about them first, so you have a quick introduction. That we'll look at the demos and stuff. But in essence, those are features which are exclusive to pipelines as code. You cannot get them with a traditional experience. So you can consider if you want to start from scratch, potentially with this, or if you want to migrate something, bear in mind that you can do more. The first one I can think of is container jobs. As you know, if you run an Azure pipeline job, you're running inside an agent. Now, with a container job, the agent will only host a container that runs the job. So the job is going to be run inside a separate container that then it can be disposed of. And that enables so many different scenarios, because think about it. If you have a standard, image that you need to use, off you go. Just run the job off your container instance. There's a question in the chat. Can you get the GUI editor on the right-hand side when you want to edit a previously edited pipeline step? Or is it only available when editing a new step? Your question, it's available everywhere. So before I show you this is an existing pipeline, Mark. So the editor is over here, hovered by a button. You see Visual Studio Code again. And if you edit something else, you need to edit something else, there you go. You can move from task to task. It works for all the tasks. Every task supports this, okay? So you don't have to use it only if you want to use new stuff. You might not want to use it at all, but if you need it, it's there, and it can be used for every step. No problem. So back to the conversation about container jobs. This is an example, and it's the example that I have of a container job. All right. My agent is running Ubuntu 16.04. My container is also running 16.04. This is the result. You see that initialize the container after initializing the job. You do whatever you need to do. You check out stop container and dispose of. So this means if we look at a more recent version, you can do things like that. So not the matrix, talk about that in a second. So the container job over here, this is a container job that was started off Ubuntu latest, so 18.04, if I recall correctly. But then my container over here is being initialized completely from scratch. So it could be anything, really. And in this case, it is 16.04. Okay? So if I wanted to use anything else, then I could do it. You shall ask, where does this container run? On the agent. So when you run Azure pipelines, you're running all your jobs inside an agent. It can be Microsoft hosted, or it can be private. Private is your hardware, or virtual machine in the cloud, or whatnot, or even a container for that matter. And the Microsoft ones are Microsoft hosted virtual machines in Azure. Now, whenever you run this, you obviously need to have a container engine on your agent, but you can definitely do it. And this runs on that hardware. So if you want to spin up multiple container jobs as part of your job, you can do it. You can use multiple containers. And I do it, for example, when I do my demo about OWASP, where I just spin up the container and I run the job of that, because that's what makes sense. You know, I already have a container image I can use. I don't want to set up hardware or configurations that then it's going to be used for a certain purpose, and it's going to be done just for the build. I want something that I can reuse. So in this case, Ubuntu 16.04, ideally, if I have a certain build configuration that I want to store, I'm not going to set up a whole set of build agents that are going to have my configuration. I can set up my container image, store it in a Docker registry, and then run every container job that I need of that. That makes much more sense. And that same container image can be used across multiple places. So you can run workloads of the container image, and one of these workloads could be a job from Azure Pipeline. So it's as simple as that. And I'm not joking when I say it's simple. That you saw the code, you saw the demo, but if I look at editing the pipeline, all I have to do is to run the VM image or the pool that I want to use. In this case, I'm using the Microsoft hosted for convenience, and then the container image that I want to use. So in this case, 16.04, because I might want something that's old, you know. But that's what it does. Seems simple, seems trivial, but it is extremely powerful because it can do those sorts of combination. And another thing that you can do on top of that, is then running multiple jobs that will have their own container image. So you can easily build up, you know, test rigs or anything that's running against specific versions. That's something fairly easy to do. Another thing, another advanced feature, and I'll go slide to demo because we'll keep it in touch and easy to consume. We have templates, and templates are so powerful. My current project is heavily using templates, and you can do so many things. So what you can do is defining build or release templates. They can then be consumed and populated at runtime. So imagine that you have a complex infrastructure deployment for your product. You will have a number of templates potentially for the various tiers or services or whatnot of your application. Now, what if you put that configuration, you put that pipeline into a template, and then you replicate the template and you invoke the template, actually more than replicating, you invoke the template just based on the target environment. So you can have an invocation of a template for a dev test environment where you're only going to pass a certain set of values and you're only going to pass a certain set of configuration steps. Pre-prod is going to be different. Again, same template, different values. It's going to do different things. Production might be different as well. You can do that, and you can also make sure that this template represents your final state of the application. It's extremely powerful. And something that goes really, really well with templates is loops. You cannot do this in a traditional pipeline. Did you ever want to run a for loop in a pipeline? I personally did before seeing this feature. I always wanted the opportunity of seamlessly running loops without having to use custom scripts. And that's so powerful. If you look at it, I put together a brief example, but template and loop looks like this. So I'm invoking a template as part of my job, and my job is going to call a set of parameters. That's an array, as you can see, cork.net, and as you actually, let's add one more. Let's add a few more, actually. We have Luke, we have .NET to core, and then we have Matteo. So this, I'm going to save it. I'm going to run it directly on master with a standard commit message. That's awful, I know. But we're going to run this. I hope it's not going to be queued because I'm running the other job. Otherwise, I'm just going to stop it. So it's going to take obviously a little while. I'm using Ubuntu 16.04 in this case. And you can see that even the internal steps are all YAML templates because that's what the engine runs on. Interesting. It's taking its time. Let me stop the other job just to be on the safe side. It should not be holding it, but yes, it is, because this is CI. There you go, triggers. Remember about triggers. All right, so now this is going to be stopped and the other one is going to start. Apologies. So if we look at it, template and loop should kick off in a moment. Yes, it is. The request has been completed, so we have it. And now you see 5 steps, 5 command line steps. Luke.net to core Matteo. This is fully dynamic. And the way that it works is with this. So you have the template, as I said, you go your template. The template accepts an array as an input parameter. I just use a very bad name called param, but you can use anything, of course. And then in the steps, you will have what's called an expression that runs, line 10, and I run the each expression. So this is a for loop, effectively. So for each p in param, parameters.param, then run the task script, echo, and the value of p. This is my template, okay? And I can, and as I demonstrated to you, it can scale and it can do anything, just depending on the value of param. So the moment I go invoking my my loop, of course, what happens is that you can just change the array and it goes. So if you have variable input parameters, you don't have to worry about building custom tasks and custom scripts. So you just save time, you introduce less problems, and you have a more consistent experience. Is it possible to execute a pipeline from a pipeline such as a deploy to 3 different production clusters? Yes, I answered your question. Ideally, you should have one template that contains your production deployment at the very least, and then you invoke it with 3 different set of parameters. As simple as that. Then you got other features, all right? So there are all sorts of things, and I'm not joking when I say there are all sorts of things. This is the invocation of a template, but there are all sorts of things really when it comes to doing things with pipelines as code. One of the things that I think is really, really powerful is the matrix. So if anybody has ever had to do product development where you have to run your testing matrix of a permutation of different configurations and operating systems and so on, it can get tedious very quickly. So this is an example of how to run a matrix. This matrix runs 2 versions of Ubuntu, 2 versions of macOS, 2 versions of Windows Server. Now, the pipeline itself is just this. I'm going to initiate a pool, well, an image based off the pool, so one of this, and then I'm going to run my pipeline, which in this case is just going to be echo, again, a script, and as simple as that. So hello from the image I'm running. The result is that invoking this means that you get this. 6 jobs created on the fly based on the matrix, and each job will do whatever is asked. So in this case, hello from Ubuntu 16.04, hello from Ubuntu 18.04, hello from macOS 10.14, and so on. Same pipeline, same concept of a template, even if it's not really a template. That's a matrix strategy. But you have a series of jobs and tasks, and then the strategy decides how you're going to run it. In this case, this is a matrix, and it's extremely powerful because doing this with the old approach, with the classic approach, was going to take so much more time. No doubt about it. And then you have simpler things as well, like if statements. So if you want to have an if statement, it's as simple as an expression. Again, in this case, I put together a simple demo that has an if statement based on the type of image used in the pipeline. So based on the image, if the image is Ubuntu latest, then runs bash If the image is Windows latest, then it runs PowerShell. In reality, if you were to run this in a switch way, so with Ubuntu running PowerShell and Windows running Bash, it would have worked anyway. But obviously, on Windows, you can't do things that are explicit to PowerShell, so to Bash. So you can't do something like setting up the time zone with TZ and using the variable to do comparisons, because obviously you don't have that on Windows. But there is Bash on Windows as much as PowerShell on Ubuntu. And this also has a nice experience, because this is a parameter that can be set and can be configured by the user. So if I want to run it, I can select what's the pool image that I want to use. So if I need Windows or Ubuntu, I can have this nice experience where I can just click and select it. There is someone with a green square around the name. I wonder if this person wants to say something or ask a question. Is it Shirag Shetty? No? Okay, that's fine, full salam. So yeah, you can do these things, and then you can do deployments as well. Because we talked about build or release, but in essence, this is an orchestrator. So if you want to pick up an example of deployment, this is it. You've got a step. Actually, sorry, this is not the right one. Sorry about that. So if I pick up, it should be this one. Yeah, the pipeline has got one. Should change the names. But in reality, what it is another job that it's identified, rather than being just a job, it is identified as a stage. So this job is going to, sorry, not as a stage, sorry, it's going to be identified as a deployment. So once you set the job as a deployment, this job will be potentially linked to an environment. You can set up the strategy as needed, and then you run the same tasks. So this command line is exactly the same command line that you can run in another job. The only advantage that you get of deployment jobs is that you get the environments hub over here. So you get end-to-end traceability based on the environment that you created. So you see MRP dev and MRP prod. Now, talking about environments, end-to-end traceability for the job is out of the box over here. Then you can get end-to-end traceability per resource. And per resource, at the moment, it means Kubernetes, and it means virtual machines, so that I can get the list of my targets that I'm running against. Obviously, you might not need that, because the moment you have end-to-end traceability per environment, you can structure your environment based on your target. So if you have, let's say, a simple web application with deployment slots, you could have an environment per slot. So you know that each environment is targeting a different slot. If you're running for a big cluster, you can have the overall environment, and then you can have each individual cluster. Why not? Again, it's all about traceability. And then, obviously, it's not like this is a new thing and it's not, and the old stuff is no longer over there. But you have approvals and checks, exactly like you would expect in any orchestrator. So you can get individual approval, groups or people, as you would expect. We also get more interesting things. Branch control, which is deployments only allowed based on certain branches. So, for example, in production, you can only deploy from master. In pre-prod, you can only deploy from a certain type of branch. In the dev test environment, you can only deploy from master or from feature branches, those sort of things. Business hours, so you can define the business hours where the deployment can happen, because you might not want to have stuff that happens within certain business hours. You can have locks. You can invoke an external Azure function for getting, a callback. REST API. You can have the gate based on an Azure monitor alerts. So once let's say once the virtual machine gets to less than 10% CPU usage, then you can go on with the deployment. Evaluate artifacts. That's interesting for container images, where you can have custom policies. So this is going to have a policy definition, and I don't think, I only have these templates, but you can have templates where like you want to whitelist a source. Okay, so I want to whitelist my internal container registry, and that's something that you can do. Or you want to forbid certain ports, like at the 1 port 80, only 443. Or you want to use images that have been built using Azure pipelines. So you can have those sort of things, and this is extremely powerful. So that once you get there, you can add this, and they add to the broader security or the broader quality. Right? See, question: can you show a pop-up, for example, to warn where you're about to deploy to production? Yes. This is actually in the stage that I. Oh no, it's still up. So you see, in this case over here, deployed straight to dev, but then I need to deploy to prod. And I know that there is an approval. I also got an email, by the way, about the approval. Here I require the approval. So there's also over here in the summary, there is an approval that I need to provide before deploying to prod. Okay, so the environment is MRP dev was done correctly. Test might be good. Yes, you see the pipeline obviously still running. It's the only one that's running on. So yeah, this looks good to me. Actually, I could, I'm looking at the log. I could accept that. It's all good. I can review that. I can say, okay, this can go on. And it could be a group, could be an individual from a group, could be, all sorts of things that you expect from an approver. So yes, I approved that. The check has passed, and now this is going to proceed. I got also an email about that. I could have clicked the link in the email, got to the same experience. All right. So, worth remembering while we start wrapping up. The two systems live together. There's no migration required. There are different features which you can mix and match as needed between the two, but remember, they are separate. So you can't do container jobs in classic pipelines, and you can't get the classic editor on pipelines as code. That said, the new editor is pretty powerful. So the choice here is always driven by the preferred approach. If your development team doesn't have the maturity to jump on board what's a fully SCode approach, take it easy, one step at a time. Start introducing the editor, start introducing how to build a pipeline as code, how to move things across from one to the other, rather than starting with everything like that from scratch. If you want to go full pipelines as code, again, be my guest. That's an excellent choice, but you don't have to choose one or the other. If you have stuff that lives in classic pipelines and you have new stuff that runs in pipelines as code, as you saw, they live in the same hub, they live in the same UI. So there's nothing wrong with them. Remember, that's something that I added. YAML is literally everywhere. So if you move to pipelines as code in Azure DevOps, you will be able to do pipelines as code in GitHub Actions too. There will be some changes, of course, but the changes are relatively limited. It's still YAML. So you will be able to get the grips quickly with a different YAML dialect and with potentially GitHub Actions. Different syntax, differences in features, of course, but the approach is the same. So remember, YAML is an investment, and it is literally everywhere. Any final question, any wrap-up question, ladies and gents? I actually got 1, 2, 3, 4, 5, 6, 7 questions during the session, 8 questions during the session. So actually, it's not too bad.
No, well, yeah, unless that's it from everyone. Yeah, you can obviously get Matteo online. Your Twitter handle is, I think it's @MattsVSTS, I think.
Yep, and that VSTS is not by chance.
Right. Well, yeah, I mean, if that is all, yeah, thanks everyone for coming. I will be posting this on our YouTube in the next day or so. And yeah, as I mentioned, I did just post the next event. Well, not the next event, it's going to be in about 3 events time, seeing as we have them every few weeks up until then. But yeah, I've just published Building Modern Applications with ASP.NET Core 5 and Vue.js 3. That's with Alexandra Malavasi. So if anyone's interested in coming to that, that's going to be on the 11th of March. But yeah, if that is it, thanks Matteo again. And yeah, we'll hope to see everyone in the next one.
Talk to you soon. Hope to see you again soon. Cheers. Bye.
Cheers guys. Bye.